So 8.1 was Pythagorean theorem, right? A squared plus B squared equals C squared, which should have looked really familiar to you, hopefully. Today, you're still using the Pythagorean theorem, but we're going to give you a shortcut that doesn't require you using the Pythagorean theorem like you did on 8.1, okay? So I'm just going to lay this out. That last question that we went over where I said, hey, this is like today's lesson, that is a segue into what you're going to do with a 45, 45, 90 triangle. So first thing you need to know is what I tell you today only works on a 45, 45, 90 triangle. So it has to be a right triangle and it has to be isosceles, right? A 45, 45, 90 means your two legs are the same. So how we're going to set this up to just see the relationship between our legs and our hypotenuse is you have your two legs that are the same, so we're going to call them both L for now. And then the hypotenuse we're going to call H, and we're just going to plug this into Pythagorean theorem right now. So if I were to set this up in the Pythagorean theorem, what would it say? What would my A be? One of the variables, right? The L, okay? Your legs are your A and your B. So if we said A squared, it'd be L squared. B squared would be L squared. And then our C is always the hypotenuse. So we're going to call that for today, we're going to call that H squared. Okay, so that's just Pythagorean theorem, right? Not doing anything fancy yet. If I simplify this, what's L squared plus L squared? 2L squared. So we have 2L squared equals H squared. Okay, now if I want to solve for H, I want to know what is the length of H. What do I have to do on both sides? Square root it. Okay, so we're going to square root both of these. Well, the square root of H squared is what? H. Okay, so that's just H. When you square root something and square it, they cancel out. The square root of 2 can't be simplified, so we're going to leave that as the square root of 2. What's the square root of L squared? L. Okay, so this is always going to be the relationship in a 45, 45, 90, where the hypotenuse is always equal to the leg times rad 2. Okay, let me show you that in terms of all L's then. So if we have a 45, 45, 90, by the way, you don't need all three angles written in a 45, 45, 90, right? You only need 145 or two 45s and no 90, or 145 and 190. So if I just gave you this triangle, you know right now that's a 45, 45, 90 because of the third angles theorem, right? Well, not third angles theorem, because of angle addition postulate. You know the three have to add up to 180, okay? So if this is my setup, this would be L, this would be L, so my hypotenuse would be L rad 2. That is going to be the shortcut you use throughout this whole section. Okay, that will always be the relationship between the three sides in a 45, 45, 90. So what we're going to do is I'm going to give you a few 45, 45, 90s, and we're going to see if we can set them up based on that relationship. Okay, so here's a 45, 45, 90. This is 8, this is X, and this is Y. Based on the way it's sitting, where my 45 is, where my 90 is, can you tell me what X should be? X should be just 8, right? Because that's one of the legs, and your legs are always the same. So if this leg is 8, then this leg is 8 also. Okay, so X would be 8. What's Y?
8 rad.
That would be 8 rad 2, right? So it's your L, L, and L rad 2. So 8, 8, and 8 rad 2. Okay, so your leg would be 8, your hypotenuse would be 8 rad 2. Questions on that? Okay, what if it looked like this instead? So this is x, this is y, and this is 5 rad 2. First of all, which side are you given right now? What, the hypotenuse, right? You have your hypotenuse side. So that is your L rad 2 side, right? If we're looking at this picture up here, you were given this, okay? So if L rad 2 is 5 rad 2, what is L? 5, right? So if this is L rad 2, we know our L would be 5, which means my two legs are both going to be 5. My x is 5, my y is 5. Does that make sense? Okay, how about this? Let's say this is 9 rad 2. Okay, that 9 rad 2 is the same as L rad 2. Right? So if that's 9 rad 2, which has to equal L rad 2, if I want to know what L is, which would be my two legs, what do? If I say 9 rad 2 equals L rad 2, how do you solve for L? Get rid of the rad 2, right? We would divide by rad 2 here, which cancels it out, and we would divide by rad 2 here. Rad 2 over rad 2 is 1, so those cancel out, and you're left with your leg is 9. Okay, so those two, right, those are the same problem. I just wrote it out as an equation to solve for L. Yeah?
We always just assume that it's going to be the number outside.
Say that again? It's going to be the number.
See how it's 9? Like, can we always assume that it's going to be the number outside of the ring?
If the hypotenuse is something rad 2, it will always be that something. So if your hypotenuse is 12 rad 2, it's always going to be 12 for your two legs. Yes. I'm going to show you for this next problem where that kind of changes a little bit, but you'll also see the difference in how it was set up. Any other questions on that? Okay. Here's where it gets a little more challenging then. You have a 45, 45, 90. Oops, that's a 5. The hypotenuse is 10, and we want to know what x is. Okay, now here's the deal. Our hypotenuse, we said, was L rad 2. Are you gentlemen back there doing math stuff? Yeah? Both staring at your iPads a whole lot right now. So if I know this is 10, we're used to that being 10 rad 2, right? Well, it's not 10 rad 2 this time. But I do know that that side is always the length of the leg times rad 2. So if I want to know what x is, I actually have to take that 10 and set it equal, not x, sorry, I'm doing this different from last year. If I call it x rad 2, I'm sorry. Last year I did it with x's and then people got confused, so we're just doing l's. So 10 equals L rad 2. Does that make sense where I'm getting that? My hypotenuse is always my L rad 2 side. If we look at our initial setup here, right, this setup, it's always L, L, and L rad 2 for the hypotenuse. So if we go to this setup then, that 10 has to equal L rad 2. How do you solve for L? You divide by rad 2. Okay, now here's the deal. You have to divide by rad 2 on both sides. So right now, it says that L is 10 over rad 2. The issue with that, and you learned this in algebra, is you are not allowed to leave radicals in the denominator. So now you just have to rationalize this. How do I get that radical out of the denominator without changing the value of my answer? Not negative. Yes, we're going to multiply by a rad 2, but we can't multiply by just rad 2 or we're changing our answer, right? If we multiply by rad 2, what number can you multiply that doesn't change the value? 1. So if we have to multiply by rad 2, but we need it to equal 1, you're going to multiply by rad 2 over rad 2, right? Now we're multiplying by 1, which is not going to change our answer. So now we simplify that. 10 times rad 2 is 10 rad 2. What is, God bless you, rad 2 times rad 2? Not 1. No. It's rad 4, which is 2, right? Rad 2 times rad 2 is rad 4. Rad 4, the square root of 4, is 2. So that would go here. So now we have L equals 10 rad 2 over 2, which you can still simplify to what? 5 rad 2, right? We just simplify that 10 and 2 to 5. So your L, your side length here, is 5 rad 2 and 5 rad 2. So X is 5 rad 2. Okay? I'm going to do another one, and then we're going to see if you can come up with the shortcut to the shortcut. Because it makes life much simpler, I promise. If you can see it. Okay, so this problem is the same as the last one. Instead of giving you a 10, I'm giving you a 14. Exact same problem otherwise. What do you know that 14 equals? Okay, so you found the shortcut to the shortcut. What if we're not using that shortcut yet? 14 equals what? L rad 2. Okay, if these are our legs, then 14 equals L rad 2. Well, if you solve this, you would divide by rad 2, divide by rad 2, so the rad 2's go away. Okay, but we have a radical in our denominator, which is not okay. So we're going to multiply by rad 2 over rad 2. That means on top you have 14 rad 2. On bottom, rad 2 times rad 2 is rad 4. Rad 4 is 2. So if you simplify that, 14 over 2 is 7 rad 2. Okay, now a few of you figured this out already, but look at these last two problems. You started on this problem. Oops, I just scribbled it out. You start, oh goodness. Am I making you dizzy yet? You started with a 10 as a hypotenuse. Your answer came out to 5 rad 2. You started with a 14 as a hypotenuse. Your answer came out to 7 rad 2. Do you see a shortcut to our shortcut? Right. So whatever that whole number is, you're cutting it in half and multiplying by rad 2. That will work every single time. Okay? So let's say my hypotenuse is 18, and this is a 45, 45, 90. What is that side? 9 rad 2. Okay? Let's say that this is 15. Okay, so here's the thing. 7.5, they don't really like decimals. So you're dividing by 2 and multiplying by rad 2. So you would just leave it as 15 rad 2 over 2, right? Because it doesn't divide to a whole number. But it's the same idea. Okay? Any questions on that? Okay, real world problem here. Ugh, who's groaning about real world? This is the world you live in. We want the real world. Okay, you are in your backyard, at a fancy hotel, wherever you want to be, and there is a courtyard that's a square that's 250 feet on every side. Okay? I want to know, if you walk diagonal across that courtyard, how far are you walking? Yeah.
How does everybody use the real life? Like in a hotel, do you even measure how far you're walking?
Maybe not like that, but I promise you, we're gonna pause real quick. Where were we? We want to know how long X is. What is it? If this is a square, that means this is going to be 45 and 45 when we draw the diagonal in, right? What is x? 250 rad 2. Now here's the deal. That is not a nice number. So usually when it's a real world problem, you just plug it in. So 250 rad 2 comes out to 353.6, and we are talking distance, and it was in feet. So that is what our hypotenuse would be. Okay? Questions on that? Okay. Yeah. I plugged that into 250 rad 2 into my calculator. Is that what you're saying?
Oh, really?
How'd I get the decimal? Yeah. I just plugged 250 rad 2 in. Okay, here's our warp speed review just to make sure you're good. I'm going to draw a bunch of triangles. Okay, warp speed review. If I am given a hypotenuse in a 45, 45, 90 of 20, what would A and what would B have to be?
Where's A? Oh.
It would be 10 rad 2, right? Cut it in half, multiply by rad 2. So 10 rad 2 and 10 rad 2. Look at this guy. If you are given 12 as your leg, what is C?
12.
C is 12. What's D? D is 12 rad 2. Okay? How about now this guy? You have a hypotenuse of 9 rad 2. What is E? That would be 9. What is F? That would be 9, right? So your two legs, your L's, and then your hypotenuse is your L rad 2. Last one, if this is 32, what is G? What?
You told me not to answer.
Oh,
Is it decimal?
it's not a decimal. What's half of 32? 16. Rad 2. What's H? 16 rad 2. Okay? If you don't want to use the shortcut to the shortcut where you just cut it in half and multiply by rad 2, that's fine. Just make sure if I'm saying, let's say it worked out to 8 equals L rad 2, right? The process is this, one last time. If you're going to solve it out the long route, you would divide by rad 2. And then you're going to multiply by rad 2 over rad 2. Okay? It is. But this, I'm saying if people don't remember that shortcut and they would rather just solve it for the variable, they can always solve it for the variable. So 8 rad 2 on top. Rad 2 times rad 2 is 2. And that 8 and 2 reduces to 4. So you would get 4 rad 2. Okay? So if you want to solve it out, that's how you would solve it. Any questions on that?